Hello, Algebra Delight students. Mr. Lawrence here, and unfortunately, I can't be in school today. My son got sick Monday night, threw up, and so I need to be home with him today. So I apologize for that. I also apologize for not assigning digits 7-3 and 7-4. It was an accident on my part when I saw the email from some of you saying that I hadn't assigned them. I was out of town, didn't have access to my computer, couldn't fix it, and so we're going to do it this way. We're going to watch a little video here. Mason, you're in charge. If Mason's not here, a former president is filling in, either David or Brandon, and you're going to watch this video. It's not going to be very long. It's going to recap 7-3 and 7-4, after which I've assigned both homework assignments. You can go ahead and do them. You can probably get one of them done in class today. Take your time, do your best, and then you can do the other one in study hall or for homework. And so by tomorrow you should be all caught up. Hopefully I should be back tomorrow, because even if my son remains sick, my wife should be able to be with him. Okay, so anyway, we're talking about linear, which was 7-3 functions, versus nonlinear functions, which is 7-4. And there's three ways that we are often presented with functions, or very commonly presented, and that would be graphs, equations, and tables. And so we're going to look at what a linear function looks like versus what a nonlinear function looks like, whether they're graphed, whether we're given equations, or whether we're given tables. Okay, so let's get to it. So here we're looking at three graphs, and this is the easiest way to tell if a function is linear or not. I mean, they're all functions because they've passed the vertical line test. You remember the vertical line test? We take a vertical line like this. Okay, pencil, a finger, something like that. I'm going to make him a little skinnier there. And I run him along the graph. And if there's any place where that vertical line touches the graph, the picture that's graphed, more than once, it's not a function. So you see this first one totally passes the vertical line test. The second one over here, it will pass the vertical line test as well. See, there's no place where it touches the curve more than once. And this one here that looks like a V, it also passes. So all three of these are functions, but only one of them is linear, and that is the first one. This is the linear one, because it forms a line. Okay? This one definitely doesn't make a line. It's said to be nonlinear. And this one, it looks like two lines, but those aren't lines. Those are rays, if you remember some lower level math that you did. I'm not sure, 6th grade, 5th grade, something like that. They're rays, because rays don't go forever in both directions. And so this is not linear either. Okay, so pardon me 1 second. Yeah, it's getting late here. It's 10:43 when I'm making this video at night. Okay, now here's equations. Now some of these are linear and some of them are not. And I'll tell you what I'm going to do. I'm going to highlight the ones that are linear. I've got this one is linear, and this one is linear, and this one is linear. Now, how are they different than the ones that I didn't highlight? Well, it's all about the powers, the exponents. If you look at the yellow ones, the highest exponent on any variable is 1, right? There's ones there, okay? And that makes it linear. As soon as I introduce like a square or a cube or a negative first, I lose the linearity. So it's not linear anymore. So the ones highlighted in yellow are linear functions. The ones not highlighted are nonlinear functions. So let's see if you can tell me what this one is. How about y equals 3x plus 5x cubed? Now if you think it's linear, you must not be considering this 3 here. See, because the power of a 3 is there, it changes it. This is a cubic, and this will not be linear. So this is non-linear. I'm not going to highlight it. How about y equals 4 minus 2x? Well, the highest exponent is 1, isn't it? And so, yeah, this is going to be linear. I'm going to highlight it. There's one more I want to throw at you here. And let's see. How about x equals 7? If you guess linear, you are correct. That would produce a vertical line. Okay. The highest power there is 1. You can have an exponent of 0, but you can't have an exponent of 2, 3, or any other higher number, or any negative number. All right? There you go. Okay, the last way we're going to look at is if the data is presented in some kind of table. And here it's going to be all about the slope. If I notice that the difference of these y's is 4, right? And the difference in the x's is 2. But the difference over here is 4. Oh, it's not 2, silly Mr. Lawrence. I'm so sorry. Let me start again. I'm getting a little bit tired and my brain is getting foggy. I apologize, ladies and gentlemen. Let me start again. Okay. Do you notice how the outputs are going up by the same amount? They're all plus 4, aren't they? They're all plus 4. And the inputs are going by the same amount, plus 1. So that would be a change of 4 over a change of 1. In other words, the slope is 4 over 1, or plain old 4. If it has a slope, a constant rate of change, it's linear every single time. Notice this one, the inputs are going up by 1, but the outputs are going up by varying amounts. 7, what do we got there? 19, and then 37, right? And then 61. They're not going up by the same amount. This one is nonlinear. Nonlinear. If they were linear, they'd be going up by the same amount. Now, you have to be careful because sometimes tables don't go up by the same amount in the input, but can still be linear. So let's see here. Here, we're going up plus 3 for 1. So we get a ratio of 3 over 1, right? The change in the y's was 3. The change in the x's is 1. But here, the change is 6 for the output, but the change of the input is 2. Is it true that 3 over 1 is the same as 6 over 2? Sure it is, because 6 divided by 2 is 3, and 3 divided by 1 is 3. Okay, let's test it again here. What's this change? 9 and 3. Oh, that would be a ratio of 9/3. It's a constant rate of change. Every time you go up 1 in the input, the output is going up 3. So if the output goes up 2, if the input goes up 2, the output is going up 6. If the input goes up 3, then the output is going up 9. This is definitely linear. Okay, this last example here, it looks like we're going up 4 in the output when the input's going up 1, okay? Now on the next one, we're going up 14 when the input is going up 2. Well, 14 divided by 2 is 7, not 4. This is nonlinear. If it were linear, it would have simplified to 4 over 1, or better yet, just 4. All right, so that's your review video. That's all it is. You can go ahead and find a partner as long as you're on task and working, and you can get the homework done. All right, so Mr. Lawrence signing off. Hopefully I'll be with you, ladies and gentlemen, tomorrow. I look forward to seeing you. Have a great day.